So today we're going to learn how to solve quadratics by factoring. Okay, it's important to remember that when I say you're solving a quadratic, you're actually looking for where your parabola crosses the x-axis. Okay, and this is so important with quadratics that they actually gave it 4 different names. When you cross the x-axis, that's your x-intercept, that's a 0, that's a root, and that's a solution. So anytime that you see any quadratic question talking about zeros, roots, solutions, or x-intercepts, they are all talking about the same thing. And we've already learned one method for finding or to solving the quadratics. Okay? The first method was when we graphed them in our calculator and we looked and we saw where the parabola actually crossed the x-axis. And that works fine. But what about a time before we actually had calculators? How did we find them back then? And for that matter, whenever it doesn't cross at a perfect number like 6 or -3, if it crosses at a decimal or a fraction, how can we find it? We won't be able to know exactly where it is on our graph, okay, because we couldn't figure out the exact number just by looking at the picture. So that's why we have a bunch of different methods for learning how to find the solutions, okay? There's other methods. Today we're learning the factoring method. Other ones, quadratic formula, square root method, on completing the squares. And they all have their different reasons. The factoring method, you can find the regular solutions, okay, whole numbers, integers, those sorts of things. You can also find fractions and you can find decimals. Now, quadratic formula and the square root method are for all the other solutions that have decimals, but those decimals cannot be turned back into fractions. For example, if I did this one, I tried to turn that back into a fraction, it did not change. So that's why we have to have so many different answers, or for different methods for doing this. Okay. So we're going to start off by factoring. Given this equation, I've got the quadratic formula equation, x squared minus 5x minus 14 equals y. If we were going to factor this thing, its factored form would be x minus 7 times x plus 2. This is equal to y. So how we're going to use this factoring method to find our x-intercepts? It's really important to remember that anytime you cross the x-axis, your y value equals 0. Okay? Cross the x-axis, y equals 0. So we're going to replace that y value with a 0 here. I've got x minus 7 times x plus 2 equals 0. Now, why does this help us? Well, if you think back, if I have 5x equals 0, that means 5 is being multiplied by something and my answer is 0. Well, the only thing that that x value could be is 0, which tells me that if I'm multiplying two numbers together, two things together, and my answer is 0, then one of them is 0. Okay? Well, whenever we have this in factored form, what we really have are two things being multiplied together, and the answer is 0, which means that one of those things, or maybe even both of those things, equals 0. And this is how we're going to find our x-intercepts. So if I know that x minus 7 equals 0, or possibly x plus 2 equals 0, I can finish the one-step problems, find my x value, and that would be my x-intercept. So right here, the opposite of minus 7 is to add 7, and I have to do that to each side of that equal sign. That cancels out, and I have that x is equal to a positive 7, or on the other side, x has a plus 2 next to it. The opposite of adding 2 is to subtract 2 from each side of that equal sign, and I'll cancel it out, which means x equals -2. Now, I don't want you guys to forget completely about the other method that we've learned. You can take that original equation that I gave you, plug it into the calculator, and find your x-intercepts. And I actually want you to continue to do that today. I want you to use that method in order to check and make sure that you did this method correctly. So we're going to go to the y equals button, clear out anything that's in there, and type the original equation that they gave us. And if you hit that graph button, you've got your parabola. It crossed at the -2, which is exactly what we had right here, and it also crossed at the positive 7. So this was one of our methods for finding x-intercepts. Okay. All right. So now let's do another example. Number 1. If I have the quadratic equation, x² minus 6x plus 8 equals 0. We've already already replaced the y value with 0, okay, because we know that anytime we're looking for where we cross the x-axis, that value has to be 0. So now I've got to factor these two things. And remember that when you're factoring, what you're actually doing is undoing the FOIL process. Okay. So if I have x squared at the beginning, that means each one of my sets of parentheses must start with a regular x, because x times x is the x squared. Now to figure out the other two numbers that go right here, I've got to find the factors of the constant, the last number that doesn't have a letter attached to it, and find the pair that adds to give me that middle number. So I'm going to take that positive 8 and list my factors. That could be 1 times 8 or 2 times 4. Well, 1 plus 8 is 9, and 2 plus 4 is 6, but I need it to be a negative 6. So remember that when your constant is a positive number like positive 8, that also means that your two factors could also be negative, because a negative 2 times a negative 4 also is a positive 8, but they add together to give you negative 6. So I've got minus 2 and minus 4. So now that I have this problem factored, I've got two things multiplied together to equal 0, so I know one or both of them equal 0. So I'm going to come across and take the x minus 2 equals 0, or x minus 4 equals 0. Then from there, all you have to do is solve the one-step problem. Opposite of a minus 2 right here is to add 2 to each side, which gives me that x equals positive 2, or on the other one, I've got x minus 4. The opposite of subtracting 4 is to add 4 to each side, which gives me x is equal to a positive 4. So these are my two x-intercepts. I didn't even have to use the calculator at all to do this, but I do want you to check your answers using the calculator. So go back to the original problem that you started off with. I've got x squared minus 6x plus 8, and I'm going to hit the little graph button to see what it looks like. That parabola crossed at the positive 2 and the positive 4. All right. Next example, number 2. I've got the problem x squared plus 2x plus 1 equals 0. Okay. Same idea. We're going to factor this the same way. Each one of my sets of parentheses is going to start off with a regular x, and I've got to take the factors of my last number. In this case, it's the number 1. Well, the only factors of 1 are 1 times 1. And those two do add to give me the positive 2, so that's exactly what I wanted. Plus 1 and plus 1. Now my question here is, I do have two things that are multiplied together to give me 0, but they're the exact same things. So really, when you have the exact same thing in each set of parentheses, you really only have one solution. So I've got x plus 1 is equal to 0. Then from there, I would subtract the 1 from each side of that equal sign, and I have x is equal to a negative 1. Well, what does that look like whenever you check your answer? Okay, I've got x squared plus 2x plus 1. If you look right here, my parabola has a vertex on the negative 1 on the x-axis. Okay, remember with quadratics, you can have 0 solutions, you can have 1 solution, or you can have 2 solutions. The most common one is when you have 2 solutions, like on example 1. Other times you might have 1 solution. Well, that's when your vertex is the only one that's touching the x-axis. The other one, when you have 0 solutions, we're not going to be doing that with any of the factoring problems. You can find out when they have no solutions using the quadratic formula or the completing the square methods or even the square root method. But for now, these are what we're going to use to be able to find our x-intercepts, our zeros, our roots, our solutions.